Cool, go ahead.
All right. Thank you very much for sticking around. I'm going to switch gear and talk about another behavior, which is addiction. So we are still in an opioid epidemic. This epidemic actually started by an overprescription of a pain drug, which is oxycodone. Oxycodone, many of you already know, it's a slow-release oral drug. When people talk about abused substances, usually those substances are inhaled or injected. So there is a very rapid accumulation of the substance in the brain, and this is associated with the euphoria. Oxycodone, on the other hand, is being formulated into a oral slow-release pill, and that's Oxycontin. Because it's slow release, controls oral pill, the pharmaceutical companies have claimed that it's safe and has very low abuse liability and promoted its wide clinical use. But oxycodone actually is not that safe, as we already find out. It has a very strong addiction liability in human, and as we are finding out, also in the rat or in other animal models. So as with many other epidemic or chronic brain disease, addiction is also better managed with early prevention. And there's a lot of individual differences in vulnerability to opioids. It's of course affected by both genetic and environmental factors. My lab is working on some environmental factors, as my student Paige talked about early at this meeting. But animal models can help us identify some of these genetic and environmental factors that contributing to individual vulnerability to the opioid. So the model we are using for this study is a oral self-administration model where we put rat into an open chamber, and in the open chamber there are two spouts. We monitor the number of licks of these rats have on each spout, and then on the so-called fixed ratio 5 schedule, meaning rat lick 5 times on the active spout, we trigger a delivery of a drop of solution to the tip of this active spout where rats are actually consuming it, and we do monitor that. So these deliveries are consumed by the rat, they are not being wasted. And at the same time of oxycodone is delivered, there is a tone and a light cue. So these are the environmental cues for the drug effect. And then the number of licks on the inactive spout are monitored as a control, and it triggers nothing. So the procedure goes something like this. We start these rats on a low dose of the oxycodone, and the session length is 1 hour to start with. And then we gradually increase the session length from 1 hour to 4 hours, and we also increase dose from 0.025 to 0.05 and gradually to 0.1. And then we change the reinforcement schedule from fixed ratio 5 to something called progressive ratio. This is a test of motivation. And then we extend the session from 4 hours to 16 hours. So these rats will have a longer access period to the drug, where some of these rats escalate their use with the increased availability of the drug. Other strains, they don't. So there is the genetic variability that we are very interested in. And then we put these rats through something called extinction session, where they can still lick, but there's no drug, there's no cues. So they basically learn that drug is no longer there. And then in the end, we put the cue back still on a fixed ratio schedule, where rats, they lick, and their responses on the active spot triggers the delivery of the cue, but there's no drug. So this is a measure of drug seeking. So this is a model we established in collaboration with a few other people, including Bert Sharp, who is also involved in this project. And to study the genetics, many of you already seen this many times. So we are using the HRDP, has two recombinant inbred panels plus some classic inbreds. And of course, these all have been fully sequenced. Here is the phylogenetic tree of these panels, and there is your FXE panel, and here are the HXB panel. Other inbred strains are here, and we have identified over 15 million variant sites across these panels. Many of them have high impact on gene expression, so on and so forth. And here are the data summarized for, this is all our data so far. We have about 200 females across 36 strains and about 150 males from 31 strains. And of course, this is still ongoing. So on the left panel is female, on the right panel is male, and the top line is number of licks on the active spot. And this is the earlier phases, 1 hour sessions, they just start ramping up. And then we still keep the same dose, but increase the session time to 4 hours. And then we increase the dose again and again. So this is the 4 hour sessions. And then we do a progressive ratio. They need to work really hard for every every subsequent reward. So the number of licks goes down. And then we increase the availability time from 4 hours to 16 hours, and you see again a ramp up of activity. And the y-axis actually is on a log scale here. And then during extinction sessions, the number of licks goes down, and then during reinstatement, a number of licks on the active spot goes up again. And this lower line is the inactive spot, and it's very clear that rats have high preference for the active spot, and they do lick some on the inactive spot, but the number of licks is very low compared to the active spot. So this is females and males, and it's quite clear from the get-go that rats lick a lot more on the active spot than, females lick a lot more than the males. So that was number of licks, and here are the number of rewards. So every 5 licks triggers a reward, but it's not always, because there is a timeout after after every reward is given, so that during the timeout period, they can still lick, consume the drug, but those licks don't trigger the next subsequent reward until the timeout is over. So this is the number of rewards from females, and this is the number of rewards from males. So here it's no longer inactive licks, this number of rewards obtained by the males. Again, there is a huge sex difference here. And then we convert rewards into an intake. Intake basically takes into consideration of the body weight. So this further amplifies the sex difference, because males in general weigh a lot more than females. So the sex difference is further amplified when you look at intake. And here is a summary in bar chart showing you the sex difference. All right, so that's the overall pattern. What about strain difference? And we have a ton of strain difference in almost every aspect of the behavior we look. Initial oxycodone intake, there's very wide sex difference. Heritability is about 0.46. And in males, still very strong strain differences. And the rest of the slides are basically showing the same kind of pattern across all these different parameters. So stable intake at 4 hours, strong strain difference. This is something that's very interesting to us. This is comparing 4-hour intake versus 16-hour intake in the same strains in females versus males. So 4-hour intake in general, in many strains, actually is sufficient for these strains. When we increase the availability, some of the strains take more, but many strains don't. So like for these strains and these strains over here, when they have a chance to take more drug, these strains actually don't escalate. They had enough drug and they are fine. But other strains, like this strain, when the drug is available, they just keep consume more and more. So this big strain difference in terms of 4-hour versus 16-hour, we think is a very interesting trait. It models where drug taking is out of control. So when with the 4-hour 4-hour access availability, some strains take enough, and when the availability is increased, some strains they don't have the same control. They just keep taking the drug, and that is true for females, and that is also true for males. It's not clear if there's a we don't have enough to tell if this is totally similar between the strains yet. So progressive ratio, again, measure of motivation, very large strain differences, and heritability in male here, it probably is just caused by this N of 1. So that's most likely going to go down when we have more animals. Q-induced relapse is the same. So what I showed you so far is very strong difference separately in males and females. What about correlation? So this is the correlation. I only show you one, but most of the other traits, when we looked at them, they are similar, showing very strong correlation between males and females, again, indicating that genetic factors play a huge role. Because this is HRDP, and we have these inbred strains, and we have many other behavior measures from these strains, and here is just a correlation plot showing some of these other measures we have. I don't expect you to read any of these, but here is the correlation between oxycodone measures, and here are some other measures from open field, novel object interactions, so on and so forth, and plasmase. So there is a lot of somewhat sparse, but a lot of correlation between oxycodone intake and measures of anxiety and novelty, so on and so forth. And the pattern seems to be slightly different between males and females. And we'll be looking more into these later. So summary, the data we have so far supports a strong genetic control of oral oxycodone intake, and the model also, the rat model of oral oxycodone also replicates some of the vulnerability of oxycodone in human. That's it.